Okay, here we go. Let's jump into this. All right, the topic is solving equations with radicals. We can make this pretty simple. There's a strategy for this, and it's not really a big deal. How do you think in a simple radical equation like that? Just use your common sense. How would you probably try to get the x by itself?
Square root.
Not square root, square. You mean, right? Square
yeah.
both sides. Because how would I undo a square root? I would square, right? So if I square both sides, let's get all the phones and stuff away, please. I don't want to see any phones out there. In pockets, completely away. Don't want to see those. If I square both sides, I get x equals 9. Now, there is something you got to keep in mind here, though. Whenever you solve radical equations by taking both sides to a power to undo the radical, which is what we're going to end up doing, there's always the possibility that you are introducing what we call in math extraneous solutions. So what that means, let me just explain that. Extraneous, let me know what that word means. Pointless, exactly. Extraneous would be, an extraneous comment would be one that just, it would be one that was not needed, not necessary. In fact, maybe even implies that it was like a waste of time. So yeah, extraneous is extra, unnecessary, pointless. When we square both sides, in this case, we create a different equation than we started with. And that equation might have some solutions that don't actually apply to the original, okay? And so we have to always check our answers. Moral of the story, when we solve radical equations, we take both sides to a power, we always end up having to take this result and put it back into the original radical equation and see if it works. Well, is the square root of 9 3?
Yes.
Yes, check. It works. So that's our solution, okay? What would have happened, though? Okay, I'm just going to make one that next to this so we can see a good example of one that doesn't work. What if we had instead, how about this? What if we'd had instead the square root of x equals negative 3, and I squared both sides? Wouldn't I have also gotten x equals 9? But when I plug that back in, it doesn't work, right? So what's going to be the result there then? If the only answer we got was 9 and it doesn't work, no, because there really isn't a plus or minus here. When I square both sides, I just get 9, right? So the answer is no solution. Yeah, it didn't work. We tried x equals 9 and it failed, right? That didn't work. And so of the one solution that we got, it was extraneous. Didn't work, so there are no solutions. That's one. There are no real solutions. And we can see right away that there aren't, because a square root always gives us back a positive answer, doesn't it? Right? I mean, if you look at a square root, but you can't take a square root of a number and get back a negative answer. And so we probably could have reasoned from the beginning that this looks weird. It's probably, it's not going to work, and it didn't. Okay. Sometimes it's not that obvious, though, as we'll see. All right, so check our solutions. Good. Okay. So what might we do with this guy? What do you think here? Now, if I've got the problem here is I've got a y stuck inside a fourth root, right? Agreed? So what am I ultimately probably going to have to do to undo that fourth root?
Subtract 5.
Okay, you're right, but ultimately you're on the right track. Ultimately, how am I going to fourth power, right? Fourth power undoes fourth root, right? Okay, but exactly. If I just try to take this immediately, take both sides of this equation to the fourth power, I'm gonna have a mess, right? Okay, yeah, well, we'll get to that. We'll get to that. But if I were to try to take this whole thing right here, would you agree this is going to be really ugly? If I take that whole thing to the fourth power, yikes. That times, I mean, that's going to be terrible. I mean, I have all kinds of radicals in it. It's going to just make the problem a lot worse than it was to start with. So instead, you guys are already on the right track. I want to get the radical all by itself on one side of the equation before I take both sides to the fourth power, right? Okay, so to do that, I would subtract 5 and then
Multiply by -1.
yeah, multiply or divide by -1. Good. and get that answer. And now that I've got the radical isolated on one side, now I can take both sides to the fourth power and get y equals 625. Okay, now what do I have to do with that? Plug it back in. The fourth root of 625 is 5. Okay, and so 5 minus 5 is 0, and so it checks out. It works. Okay, yeah, how about that?
This is rad.
Okay, now let's look at two slightly different problems, but only slightly different. I want you to see that this is really just more of the same stuff. What about the one on the left? What if I've got 3x to the 4 thirds equals 243? Now, x to the 4 thirds, let's just talk about that for just a second. What does that mean? X to the 4 thirds. Okay, it's x to the 1 1/3, sure. But if we look at that fractional exponent, remember, what is it? The bottom is what's really kind of important here. What does that 1/3 mean on the bottom? Perfect. Okay, this is equal to, that means the cube root, doesn't it? It's the denominator that tells you what kind of root it is. So this is the cube root of x to the 4th, or I could write it this way, the cube root of x to the 4th. Take your pick. Either one of them works. But the main thing is, it's a cube root, isn't it? Right? Okay, so if I want to solve this guy then, I'm going to be dealing with this, even though it doesn't look like a radical in the beginning, it really is a radical. It's the same kind of thing we just dealt with. Yeah. Yeah, in a way I think it would be. Yeah, you're right. So what about this guy on the left here then? So I could divide both sides by 3 to get that x to the 4 thirds by itself, right? And really there's two things I could do now. I could cube both sides, right? And I could do that, that'd be fine. What happens if I cube both sides? If I cube both sides, x to the 4 thirds cubed equals 81 cubed. If I take a power to a power, what am I doing? I'm multiplying the exponents, right? What's 4 thirds times 3 over 1? 4, right? The 3's would, I get 12 over 3, which reduces, right? I can just cancel the 3's. And so I'm going to get x to the 4th equals some huge number. And now what would I do? 4th root. Sure, now I take a 4th root of both sides, right? And so I would get x equals the 4th root of whatever my calculator tells me that is, 81 to the 3rd. But what do I need if I take an even root of both sides?
Plus or minus.
Plus or minus, right? You see?
How do you know when to use plus or minus?
Well, because whenever you're taking a root of both sides, if it's an even root, I need a plus or minus, right? So for example, let's just quickly review that, because that's a big deal. Okay. If I'm doing something like this, if I have x cubed equals 27, what do I do to get the x by itself? Cube root. So x equals the cube root of 27, which is 3. Do I need a plus or minus? No, I don't. Don't need it because 3 is odd. I took a cube root of both sides, right? But compare that to, what if I have x to the 4th equals 64? What do I do?
Fourth root.
You gotta do plus or minus.
4th root of 64, which is, I probably picked the bad one, didn't I? Oh, that's just 4, isn't it? Oh, no, it's not. What I meant to do was make that a 16. How about it? Let's do that. That makes it easier. Here, let me start this. But this time, because that's even, I need that plus or minus. Whenever I take an even root of both sides, I gotta put the plus or minus, not for the odds. That's the difference. So my answer is x equals plus or minus 2 for this one. Okay? So in this case, I need to have that plus or minus there because I've taken a 4th root. Okay? Now, that's the same thing. Those two steps can be combined by just doing this, by taking our x to the 4 thirds to the 3/4 power. Isn't that the same deal? Cubing and then 4th rooting, right? Easier. So the rule we can come down to here that'll make your lives a little easier is when I want to undo a fractional exponent, I'm going to take both sides to the reciprocal power. Okay? Right? But I do need in this case, because here's the one thing you got to be very careful with if you make this one step. Here's where you could mess this up. If the bottom is even, that's the root part that I'm doing, right? If the bottom of the fraction is an even number, what do I have to include? Plus or minus. Good. Okay. Okay. Make sense? And that's something, the 81 to the 3/4, typically that's something you can just do in your calculator, although we wouldn't need to, because the 4th root of 81, remember if I try to evaluate, or if I want to evaluate one of those without a calculator, remember what this means. 81 to the 3/4 means the 4th root of 81, you start on the bottom, which is 3, right? 3 times 3 times 3 times 3 is 81. So that's going to give me 3 cubed, right? So there's my 27. Plus or minus has to be there because that's even. Make sense? Takes a little practice, but that's it. I mean, essentially, that is what you do. That's how you solve radical equations. There's some rules you got to remember with that. That plus or minus one, it can be a killer. That's easy to forget. But if you remember that, there's not a lot to it. Okay, so what about this guy over here then? What would we do with that? So I'm going to add 4, right, to both sides to get rid of that 4, so I can isolate the radical. Once I get the radical by itself, I'd have to check both of those. They'd both work. Once I get the radical by itself, now what? If it's a square root, how do I undo a square root? Square it. Square both sides. So that's going to undo the radical on the left. I'm just going to get a 2x plus 8. 10 squared is 100, right? Yeah, now I just solve for x, right? So subtract 8, divide by 2, and there's my answer. But what do I have to do?
Plus or minus.
No, not plus or minus. Plug it in. Got to check it, right? And the reason I have to check it, here's why. The reason I have to check it is this step right there, because I took both sides to a power, right? Whenever you take both sides of an equation to a power, that's where you possibly introduce those extraneous solutions. And from that point on, you got to be aware of that and check it, okay? Check your answer. Okay? And that one would work also. Okay, now the hardest ones we could do. And this is really, once we get to here, this is as hard as it could get in Algebra 2. On the left side, what do you suppose we're going to do with that guy? I got 2 radicals in the equation. Say it again. Well, I don't just have a 2, I have 2 times the square root of x. But why not add that to both sides? Now, look what I've got 2 terms, each of them has a radical. So really, if I isolate one radical, aren't I also isolating the other radical? Now, it's not going to be completely isolated. It's still got this 2 out front. But that's not a big deal. If I square both sides now, what's going to happen? If I square the left side, what's that going to end up being? Yeah, 12 minus 2x. I'm just going to simply undo the radical, correct? If I square the right side, now let's just look at that real quick. If I square that right side, if I take the quantity 2 times the square root of x squared, think about that for a second. What's that going to give me? Okay, 2 squared, I got to distribute, right? 2 squared times the square root of x squared, and what's 2 squared? Square root of x squared? There you go, right? Okay, so if let's just click through this then. So we get that, and now what? Solve it. Yeah, solve it. So add 2x to both sides, divide by 6, x equals 2, and then last step, got to plug it in and check. So let's see, what would happen if I plug that in? I get the square root of 12 minus 4. I get the square root of 8 on the left side, right? So let's just check this. So this side gives me square root of 8. On this side I get, or a minus 2 times the square root of 2. Whoops. So does that equal 0? It does, doesn't it? I could simplify the square root of 8 if I wanted to. The square root of 8, I could break up into the square root of 4 times the square root of 2, right, which is just 2 radical 2. 2 radical 2 minus 2 radical 2, yeah, that equals 0. So it does check out. Okay? And even with a non-graphing calculator, how could we check that with the calculator?
Plug it in.
Yeah, plug it in. Just see. See if the square root of 8 minus 2 times the square root of 2 does equal 0, and it does. Okay? All right. What about this side? Same deal, really, isn't it?
Yeah. You add,
Right? So I'd add this term to the other side. Add the 3 times the square root of 2x. Square both sides. What am I going to get on the left? Yeah, 4x plus 28. Just cancel the radical. On the right side, 9 times
4.
times 2x, right? Because I'm just canceling that radical. Okay? So 4x plus 28 equals 9 times 2x, which is just 18x. Solve it. Subtract 4x, divide by 14, x equals 2.
Check it.
Check it. And that one I think would work too, wouldn't it? Yeah, that would work. Okay. Okay. What about there's something different with this one though? Something different. It's no harder. Well, maybe it's not really. What's different with this one? Well, there's only one radical. Yes, ma'am.
Yeah, if you square both sides, you get like square in that.
Ah, okay, good. You're right. When I square both sides, if I square the left side, I'm getting the quantity x minus 4 squared. On the right side, I'm just getting a 2x. But if I FOIL out x minus 4 squared, think what that's going to, and we have a pattern for this. Remember what the pattern is? Let's quickly, if I have a plus b squared, what's my expansion pattern? You don't want to FOIL it out every time. Good, a squared plus 2ab plus b squared, right? That's a lot faster. So in this case, what's our a? X, what's our b? Negative 4, right? So if I plug that stuff in, I'm going to get a squared is going to be x squared. 2 times x times negative 4 would be negative 8x. Negative 4 squared would be 16, right? Yeah, and that's, once you do that a few times, really, that's a better way to do it. It's a lot faster. Okay, so if I expand that out, I get that, right? Now, okay, where are we going? What are we going to do with that now? Okay, well, once we FOIL it out, though, we still get squares in there. What are we going to do with that? Anna, you know, we can do that. Subtract 2x, put it in standard form, right? And then it's just a quadratic equation in standard form, right? Now we just got to solve that. We got all kinds of options. If it factors, great. If it doesn't factor, what do we always fall back on? Quadratic formula. Well, this is check. Are there magic numbers that multiply to positive 16 and add to negative 10?
2 and 8.
Yeah, negative 8, negative 2. Perfect. So that actually works, doesn't it? And then, so what would my zeros be?
8 and 2.
8 and 2. When I set those equal to 0, apply the zero product property. I got a product of factors, set the factors equal to 0. I get x equals 8 and x equals 2, right? Now, what do I have to do?
Check.
Check them. I got to check them. Okay, let's see what happens. If I plug in, let's see, the 8. 8 minus 4 equals the square root of 2 times 8. That works, doesn't it? I get 4 equals the square root of 16. 4 equals 4. Okay, that works. How about this guy over here? 2 minus 4 is negative 2. Square root of 4 is positive 2. That doesn't work. Doesn't work. So we have to discard that one. That one's a no-go. That was extraneous. Only one of them worked. Okay? So why didn't one work? Well, we basically already covered that. Extraneous solution, right? False solution, and we just, whenever we take both sides to a power, we could get those, right? Okay? So that's it, to the loud. That's it for chapter 7. I got the assignment up already?
Here for the rest of the day.
No.
Stop picking on me, Quentin. You're picking on me.
You bully, Quentin.
He's a bully.
Is there gonna be a 7.6?
Yes, I need to do that. There will be.
Is there alternate activity?
Yeah, 7.5 was the first. Yep.
Are you gonna follow it right over?
Yep, I'm coming down there right now.
There was one?
Hang on. We gotta see if
Yeah.
205 is available. If not, we'll go somewhere else.
Oh, actually,